Hello and welcome to Mr. Hayes' Classroom Lessons, where this week we are talking all about function machines. Now, function machines is something that comes up year after year in the transfer test, and we will be looking at 3 different examples today, very closely linked to the style that they are presented in the transfer test, and that's important. It's okay looking at function machines in general, but we have got to be specific to the style that they appear in the transfer test themselves. So, without further ado, let's jump in. Now, this brief lesson overview gives you an outline of what we're going to do today and how I suggest you best use this. We're going to have our main teaching first of all. We'll cover what function machines are, and then we will look at question examples that get progressively harder as we go on, and all of these are very closely related to ones that have been seen on previous transfer tests. Then we'll take a look at the key learning notes that we need to remember, and importantly points 4 on 5. Using this information now to get additional practice put in, maybe straight after we have watched the video, and then before you begin your next revision session or start the next revision topic, you cover it again to make sure you have secured the knowledge from the previous lesson. That's a good routine and a good pattern to follow. Cover the topics, give it a few days, begin your next session with a few examples and a few questions based on the previous topic before moving on to another one. It's good to check that you have secured that knowledge. If not, make a little note, come back to it a bit later down the line that you need to cover this topic again. Okay, so what is a function machine? A function machine is a way of writing rules using the 4 operations add, subtract, multiply and divide that leads you through a flow diagram with a number that results in an answer. So if you have the starting number, you just follow the operations that are set out for you in the flow diagram to lead you to the end number. If you have the end number, you have the answer. You've got to go backwards through the flow diagram and carry out inverse operations. Okay, so the opposite operations. We go in reverse and we reverse the operations. And that would lead you to the starting number. So we're going to take a look at a few examples, some basic ones, working up to some tricky ones that you need to be aware of. Right, so let's take a look at what has happened here as we move through the calculation. We started off with 8 plus 6 gives us 14. Multiply that by 3 gives us 42. And then we go 42, take away 0.5 gives us our answer of 41.5. So we have applied the operations in order, in sequence, as we move through the flow diagram and the function machine to give us our answer of 41.5. Now, in our second example, what we've got this time is the answer, but we have no starting number. So we're going to have to go in reverse through the flow diagram, through the function machine to try and calculate the starting number. Now, in a situation like this, we do inverse operations. We do the opposite operations to everything that's written down. So here, where it says minus 0.5, we will add 0.5. Instead of multiply by 3, we will divide by 3, and instead of add 6, we will subtract 6 and hopefully end up with the right starting number. So let's have a go at that. So we've got 41.5 as our starting number, and instead of subtracting 0.5, we add 0.5, which gives us an answer of 42. 42 times 3 would become 42 divided by 3. 42 divided by 3 gives us 14, and 14 subtract 6 because it's the inverse operation leads us back to the number 8 where we started off from. Okay, so there is the same example but applied differently. One where you had the starting number and had to flow through the diagram, and one where you had the answer and have to do inverse operations leading backwards. Now, something to be aware of, sometimes there are some tricky questions, especially in the past few years. They have started putting in multiplying and dividing by decimals. So be careful as we head through. They sound straightforward, but when you see a multiplying or dividing by decimal numbers, be careful. Let's have a look. Why? Our starting number is 11, okay? And the first thing we're going to do as we head through our function machine, our flow diagram to the end, 11 plus 17 is 8, no problems there. Now we're multiplying by 0.5. Now, if you've done your work on decimal fractions, you'll know that when you multiply by 0.5, you're multiplying by a half, which means you half that number. So 18 multiplied by 0.5 gives you 9. 9 take away 4 gives you 5. Okay, so be particularly careful when you see a multiplying or dividing by a decimal fraction. If you're reading your questions in the transfer test and you see a multiplying with a decimal fraction, be alert, be aware that that's the tricky type that you've got to be especially careful of. Now, that one we went through our flow diagram normally to lead us to the answer. This one is going in the opposite direction to try and give us our starting number. So let's take a look at what we would do here. 5 take away 4 becomes the inverse operation because we're going in reverse. So 5 plus 4 gives us 9. Instead of multiplying 9 by 0.5, we are now going to divide 9 by 0.5. So how many halves are in 9? Well, you would double the 9 because there's twice as many halves. And that would give us 18. And then 18, instead of plus 7, we would subtract 7. And that gives us 11 back where we started off on this one. So be very careful with these types of questions. Out of all the examples we've looked at, those are pretty straightforward. This is not too tricky. We are doing inverse operations going backwards, and be especially aware of this if you see a multiply or divide by a decimal fraction that you're on red alert. That is definitely a trickier type of question. So that is function machines and the 3 styles that you are likely to come across in the transfer test. What I suggest you do next is that you take those 3 styles and you put them into practice with some revision questions. Now, practice the ones where you go looking for the answer at the end of the function machine, practice some where you're looking for the starting number, and practice some where you're using decimal fractions both going forwards and backwards through the function machine, using your inverse operations or going in reverse when necessary. Next up, I'm going to include the key notes from this lesson, and then I will see you all for the next topic.